Okay, fractions and rational expressions. So we're going to start off with just a review of fractions. And what we're going to do is start off by just reducing fractions to lowest terms. So we'll call this Part A. Number one, reduce the following fractions to lowest terms. Reduce the following fractions to lowest terms. A, 4 over 14. So, what is 4 over 14 reduced to lowest terms? 2 over 7. And how do we do that? What did you do to get that? Divided by 2. Divided what by 2? Top of the bottom. Because they're both even, so we know they're divisible by 2, so we did that. Okay, can we go any lower than 2 over 7? No. Why not? So the technical thing is they do not share a common factor. Remember factoring, factor down a tree and all that stuff, right? When we factor. So 4 is factored as 2 times 2, and 14 is factored as 2 times 7. And since they each have a 2, we can divide that out, and we're left with 2 over 7. 2 and 7 do not have any common factors, so this is in lowest terms. Okay? B, 12 over 20. What's 12 over 20 reduced to? So let's say I do what we did last time. Let's just divide both of them by 2. That'll give me 6 over 10. Is that in lowest terms?
Do it again.
Do it again. What do I get? Okay? So you can reduce in multiple steps. Nobody cares, right? Nobody says, you did that in 2 steps and somebody else did it in 1, right? It's just get it in lowest terms. What are lowest terms? No common factor between the numerator, that's the technical word for the top term, and the denominator, right? No common factor. Okay? So what we could have said is, if I divide by 2 and then divide by 2 again, I could have just divided by 4, right? So really we're looking, when we get into, we're looking for the largest common factor. What's the biggest number that goes into both 12 and 20? It's 4. 12 divided by 4 gives me 3, and 20 divided by 4 gives me 5, right? And then we check again. Just make sure, right? Can this? No, that's good. Okay, C, 21 over 45. What are we going to divide by? By the way, your calculator will do this for you, you know. I can show you. Ask me. I can show you how. 7 over 15. So what are we dividing by? What number goes into both 21 and 45? Not 2. 3. Okay, so I divide by 3. 21 divided by 3 is 7. Now at this point, 7 is a prime number, so I know I'm it, right? This is the lowest that I can go, because there's nothing that divides into 7 other than 7. And this, 45 divided by 3 is 15. Now, if this had a multiple of 7, then actually I could go lower, right? Because they would not be, what we're looking for is not necessarily that they're prime, but that they're relatively prime. Relatively prime means that they share no common factor. Okay, so like 4 and 9 are not prime numbers, right? Because 4 is 2 times 2. But they are relatively prime in that they share no common factor. So 4 over 9, that's it, done. Can't reduce it, right? They don't share any common factors. D, 42 over 24. I'd show you how the calculator does it, but you need to think when you're, because it's good to get to practicing. Well, what's the biggest number that goes into I would start with 2. Does 2 go into both of them? Yeah? Okay. What about 3? I think 3 goes into both. Well, 2 and 3 both go into them, then 6 has to go in, right? Because if 2 and 3 go in, 2 times 3 is 6. Okay? If I divide the 42 by 6, I'm going to get a 7. And remember, 7 is, well, 7 is prime. So divided by 6, we get 7. Divided by 6, we get 4. That's it. Okay. Reduce to lowest term. Now, this is also, or looking back at this one, no, I circle that because when I say on the video, looking back at this one and don't do anything, it's like, where are you looking? Looking back at this one, you can see that 12 over 20, these are called equivalent fractions, right? 12 over 20 is the same as 6 over 10 is the same as 3 over 5. Why might I want to turn 12 over 20 into 6 over 10 instead of 3 over 5?
To add or divide with another one that has a denominator of 10?
Yeah, so if I wanted to add 12 over 20 with 3 over 10, and 3 over 10 is already reduced, then I could say, well, I need 12 over 20 and 3 over 10 to have a common denominator for adding, which would be 10, and so I would convert it to this so that I could add or subtract, right? So there are equivalent fractions, and then there are lowest terms. Okay, we good? Any questions on? Okay. 2, evaluate and express in simplest form. Evaluate. What does evaluate mean? How do you spell simplest? Simplest. So what does evaluate mean? Or what's another way to say it? Solve it, work it out, yeah. Okay, so evaluate it. Evaluate means come up with a value, right? So, you know, in this case, you're probably doing some operation. So A, 1/2 plus 1/3. Okay, we're adding fractions. In order to add fractions, what do we need? The bottom to be the same. Another way of saying that is a common denominator. What is the common denominator for 2 and 3? 6. So we need to write 1/2 as something over 6. So what is 1/2 when it's written as something over 6? 3 over 6. How do we get that? Okay, times top and bottom by 3, right? So you say, well, I need this to become a 6. That's going to happen by multiplying by 3. But if I multiply just the bottom by 3, then I've changed this, and I don't want to. So I also multiply the top by 3. Okay, we need a 6. What's 1/3? 2 over 6, right? Again, so how do we do it? Okay, so let's throw an equal sign in there because this expression is equal to this expression, right? They're the same. And what's 3 over 6 plus 2 over 6? 5 over 6, right? So we know how to add fractions. We need a common denominator. When we add them, we add the numerators together. We leave the denominator the same, right? It's like apples. These are apples. So I got 3 apples and 2 apples. You know, add 5 apples. 4/5 minus 3/4. LCD. That stands for lowest common denominator, right? It's just easier to say. LCD also stands for liquid crystal display, but good morning, please excuse. This will be on the video, right? I should get rid of that. Get that. You know, any announcements that come over, they all end up in there. What's the LCD? 20, right? What's the biggest number that 5 and 4? So what do you do? Here's how you find an LCD, right? You start with the bigger number, 5, and you start taking multiples of it. Okay, so 5. No, 4 doesn't go into that. 2 times 5, 10. 4 doesn't go into that. 3 times 5, 15. 4 doesn't go into that. 4 times 5, 20. 4 does go into that. Okay, so you just take the bigger number, keep doing multiples of it until you find one that this goes into. In this case, it's the 2 of them multiplied together, as was this case, right? Again, why? Because they're relatively prime. They don't share any common factors. If they shared a common factor, we wouldn't need to put that in multiple times. Maybe we'll see that in a future example. Okay, what's 4 over 5 when I make it something over 20? 16. What's 3? 4, what is this? 15. What's 16 twentieths minus 15 twentieths? 1 over 20. Yes, we're good. And again, at any point, if you have a question, please ask. 3/8 plus a half. Bless you, yes. 3/8 plus 1/2. What's the LCD? 8, right? Because the 2 goes into the 8. So we don't need to go any further, right? So 3/8 is 3/8. 1/2. If I'm going to write it over 8, what is it? 4. And what's this? Okay, 7 over 8. Right, we good? D, 4/15 minus 5/12. LCD. There's another way to do this. Remember factor trees? Okay. 60?
Yeah, 60.
Yeah, it is. Okay. So how'd you get 60? Start taking multiples of 15, right? So 15, 12 doesn't go into it. 30, 12 doesn't go into it. 45, 12 doesn't go into it. 60, 12 does go into it. Okay, what's another way? Think about a factor tree, right? 15 is 3 times 5. Okay, that's it. 12 is 4 times 3, which is 2 times 2 times 3. Sorry, just circle the primes. So the lowest common denominator, I need a 3 and I need a 5. I don't need another 3 because I already got one, but I need 2 2's, right? So it's 2 times 2 times 3 times 5, which amazingly is 60, right? So that's another way to come up with the lowest common denominator, right? Is to do a prime factorization and say, need a 3, need a 5, need a 2, need another 2, already got a 3, so I don't need to write that one again. Okay, what's this? How many 60ths? 16, right? Because how do we get 15 to be 60? Multiplied by 4. And how do we get 12 to be 60? And 16 minus 25 is -9 over 60. Does this reduce 5 over 6? Does this reduce 1 over 20? Does this reduce 7 over 8? Does this reduce? Yeah, it does, right? So what does it reduce to? Okay, well, they're both divisible by 3, right? Oh, why is that? Well, because we got that 3, and so. Okay. That's actually coincidental, right? It all depends on the number there, but they're both divisible by 3. Okay, because 3 is a factor of the 60. So what factors, we look at 60, right? It's made up of a 2, a 2, a 3, and a 5, so any multiple of 2, 3, or 5 up here will reduce, right? Because we can cancel it with one of the factors of 60. Okay, good? Okay, next, evaluate and express in simplest form. Well, not the one we just did. Yeah. Evaluate and express in simplest form. It's important on a test to do this, which stands for what? Read the question. Okay? Read the question, honestly, because you know, you'll get it back and you're like, oh, yeah, it was asking this. I gave it that. Okay? Why does that happen? Well, because you do a bunch of homework that has a particular thing. You get this pattern in mind, right? When I see this, this is what I do. And so you just automatically do it, but that's not really what it asked for that time, right? So it's a variation. So read the question. What do they want me to find? I need to understand this. Okay? You will find, if you were to compare the 30-1 and the 30-2 diplomas, look at them, which you don't get to do, but I do, you'll see the 30-2 is a little more wordy. Okay? And the reason is they tend to set up situations in more of a context. Right? 30-1, it's like, do some math, do some more math, do some more math. Here's more math, here's yet some more math. Yours is more like, do some math, but the context is this, right? Here's a situation where blah, 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 so there's context in the question, and then you do some math. Okay? But that means you have to do a little more reading, so read the question carefully. Anyways, evaluate and express, what were we? 1/4 times 2/3. Okay, we is multiplying.
Oh my God.
What does we get? Two over 12, right? So when you multiply fractions, what do? You multiply the numerators together, 1 times 2, and you multiply the denominators. So 2 over 12. Is that reducible?
Yeah.
2? 1 over 6, right? Okay. B, 4 over 15. Okay, what do you want to do? I'll do it any way you want me to. Here's the #1 reason for not using your calculator to do this. When we do rational expressions, there's variables in there that we don't get to do that, right? You can't throw x's into your calculator and have it do calculations. So, you know, we need the basic skills without the use of the calculator. Just you can use it to verify. So, what do you want to do? Do it. 2 ways, 2 things I could do. No, no trees here. Trees are for adding or subtracting, right? 'Cause we don't need a common denominator. When you multiply, it's numerator times numerator. So, simplest thing you can do is what? What's 4 times 5? 20. What's 15 times 6? 90. Does that reduce?
Yes.
To what? 2 over 9, right? We just divide by 10.
Get rid of the zeros.
Yeah, you lose the zeros, right? How do you lose a 0? You divide by 10. So the common factor is 10. Is there another way to do this question? Okay, what if I do this? What did I just do? Cancel common factors top and bottom, right? 5 goes into 5 once and into 15 3 times. I'm going to have to take them out at some point. I could take them out now. 2 goes into 4 twice and into 6 3 times. Up top I have 2 times 1, which is, and on the bottom I have 3 times 3, which is, okay. Either way, right? Doesn't matter. We get 2 over 9 either way. Nobody cares how you did it. Okay, it's not a big deal. Okay, let's do some more. C, 3 over 10. Okay, what do? 3 over 10 divided by 4 over 15. Dividing fractions, you should do something. What's the rule? Come on. One of you knows this. Say it, however you learned it. Anyone? Flip it. And do what with it? Thank you. You rescued us. Yeah, multiply and flip. So some people call it kiss and flip, right? The X being the kiss and then flip. Some people say invert and multiply. That's the way I learned it. Invert and multiply. So it's times, okay? So kiss and flip, invert and multiply, whatever you like. And when we divide fractions, we multiply by the reciprocal, right? Which is to basically just flip this over. Don't flip the first one. No, you only flip one thing. You flip them both, you just end up with something weird. Okay. Now what? Your choice. We can go 45 over 40. We can cancel a 5 into here and here. 45 over 40. Okay, which reduces to? What goes into both? 5. 5 goes into 45. And 5 goes into 40. And we get 9 over 8. Okay? People who like to cancel would say 5 goes into that twice, goes into that 3 times, and we get 9 over 8. Okay, your choice. Matters not to me. 4 over 21 divided by 8 over 14. Equals, what am I going to write next? You got the model in front of you, so what do we do? 14 over 8. Right? So if you run into problems doing the book stuff, look at the examples in the book, right? There'll be different examples. You can say, all right, what did these guys do? You know, I'm going to show you one way. Okay? That's the way that works best for me. You know, but there are other ways, and the book will often show you other ways. Okay? What do you got? Alright, this is what I would do. 4 goes into 4 once and into 8 twice. 14 and 21 share a common factor of 7. 7 goes into 14 twice and into 21 3 times. 1 times 2 is 2. 3 times, oh wait, the 2's cancel. So we're just left with 1 over 3. Okay, which we didn't write very well. Other people might say 4 times 14 is 56. Is it? Yes, it is. 21 times 8 is?
168.
168. Now we got to reduce that. Okay, well, you look for numbers. Well, 8 goes into that, right? Like 7 times, I think. And 8 probably goes into that like 21 times, and that's 1 over 3. So you'll get there eventually, right? So I like doing this because then I don't have to do this, right? I don't have to simplify a more complicated fraction, okay? Personal choice, though, right? Whatever you like. Questions? Okay. That ends our review of, what, middle school? I don't know. Where do you do that kind of stuff? Okay, so here, the grade 12 stuff. That's what we're hitting now, right? Rational expressions. Part B. So if you looked at that and said, that's easy, that's good, right? And if you looked at that and said, oh, I need to remember my fraction stuff. If you need practice with fractions, right? Khan Academy. You heard of Khan Academy? If not, I'll write it out, right? Khan Academy. Khan Academy has a million videos, not a million, but they got lots of videos on all different subjects, right? Economics, chemistry, physics, math. And, you know, the math will go back to elementary and middle school math. So if you just need a quick review on something to do with fractions or factoring or whatever, it's a good place to go. Or just go into YouTube and type in adding fractions or something, right? Like, you know, so if you need a review on something, go find the material. It's out there, you know. Okay, so Khan Academy, decent place, not bad videos, they're relatively short. Okay, rational expression. So let's start off by defining it. This will also be defined in your book, right? usually in green, move that up there. So usually in green in the margin or something, right? They define a rational expression. The first time they use any term, they tend to define it somewhere. So it's a fraction that has a polynomial for both the numerator and the denominator. For both the numerator and the denominator. Okay, whoa, polynomials, right? That's the first section we did, polynomial functions. Well, so it ties in, right? You never leave stuff behind. It comes back. So polynomial, right? So it could be anything, right? You could have, well here, 1 over 2. They're both polynomials, right? Kind of simple. It's like just what we called a fraction, okay? But you could have 10 over x minus 7. 10, also a polynomial, right? Even though it doesn't have an x value with it, right? It's a constant term, right? It's a polynomial of degree 0. This is one of degree 1. Okay, let me throw a comma in there. Or you could have there, rational expression. Right? One polynomial over another. Okay. You probably won't see stuff like that, but you will get similar stuff. Equivalent rational expressions. This is like a sentence. Can be determined by multiplying the original fraction actually let's call it the original rational expression. The original rational expression multiplying the original by a fraction, I'm just going to move this, by a fraction, which could be a rational expression, there. So, equivalent rational expressions can be determined by multiplying the original by a fraction, i.e. rational expression, equivalent to 1. Okay, just like we got equivalent fractions, right? We multiply or divide by the same number, right? We're going to multiply top and bottom by 3. We're going to divide top and bottom by 4. We get an equivalent fraction. Well, in the same way, we can get an equivalent rational expression, right? So in other words, multiply the numerator and the denominator by the same value. Multiply the numerator and denominator by the same value. Okay, so those are equivalent rational expressions analogous to equivalent fractions, right? So what we just did with fractions, making 2 over 4 the same as 4 over 8, we do the same thing with rational expressions, making one equivalent to the other. So let's do that. Determine two different, number 4. Determine two different rational expressions that are equivalent to the following. Two different rational expressions Okay, determine two different rational expressions that are equivalent to the following. Okay, what do you want to multiply by? Pick a number, any number. 3? Okay? Any number. Okay, so we're going to multiply by 3. It's got to be 3 over 3, right? Because what's 3 over 3 equal to? 1. If we multiply by 1, we don't change the value, right? We're going to change the expression, but we won't change its value. Okay, what's 3 times 3x squared plus 9x? Okay, let's do it one piece by piece. What's 3 times 3x squared? 9x squared. What's 3 times 9x? 27x. What's 3x times 3? 9x. Okay, that is an equivalent rational expression, right? Saying these are the same. Okay, these are the same. How do I know they're the same? Well, I could put the same value in for x. Like, if x was, pick a number, any number.
5.
We'll go with 5. Actually, let's go with 2, because it'll be easier to do, right? Okay, if x were 2, then this would be 3 times 2 squared plus 9 times 2 over 3 times 2, right? Which is 12. Plus 18 over 6, which is 30 over 6, which is 5, right? And if x were 2, this one would be 9 times 2 squared plus 27 times 2 over 9 times 2, which would be, this would be 36, right? 2 squared is 4 times 9, so that's 36 plus 54 over 18. Okay, 36 plus 54 is 90 over 18, which is 5. They are equivalent rational expressions since when I put the same value into them, I get the same value out, right? Doesn't matter what I put in. I put 117 in for x here. I put 117 in for x here. I will get the same value out of there since they are equivalent. Okay. But there's a value of x that I cannot put into here. What value of x can't I put into here? 0, right? Because what happens if I do that? You end up dividing by 0, and that's not allowed, right? So then we'll get into that in a second, right? But it's called a non-permissible. Okay, we need one other equivalent to 3x squared plus 9x over 3x. So what else can I do to this? I multiplied by 3. We could divide by 3, right? I don't even know how to write that. I guess you could say we're going to multiply by 1/3 over 1/3, because dividing by 3 is like multiplying by a third, right? So a third of this will be x squared plus 3x, and a third of this will just be x, and there's another equivalent expression, right? So I put a 2 in here, I get 4 plus 6, which is 10, over 2, which is 5. So it's another equivalent expression, right? And today only, bonus. Let's do one more. I'm going to multiply by 7x squared over 7x squared. Okay? Why might I do that? Well, maybe I have another expression whose denominator is 21x cubed, and I want to add or subtract. So I need a common denominator, right? So we have to change the form of the rational expression. What am I multiplying by? What's this equal to? 1. So I'm changing its form, but not its value, right? And if we went in and after, well, let's do this first. Okay. So 7x squared, that's going to be 21x to the 4th plus 63x cubed over 21x cubed. Okay, that's another equivalent. If I stuck a 2 in there, which I have no intention of doing, it would work out to 5. Right? You got calculators. You want to go 21 times 2 to the 4th plus 63 times 2 cubed, hit enter, go divided by 21 times 2 cubed, you'll get 5. Right? It's an equivalent rational expression. Why do we do that? Because I might need the same denominator, so I need to be able to change the form of a rational expression, but not its value. Right? It's always going to evaluate to the same thing. Okay, one more. How about 3 minus 5x over 4 plus x? Okay, what are we going to do? Yeah, whatever you want, okay? Who wants to do something? Multiply by what over what? There's too many choices. Let's multiply by 2 over 2 then. Right? I can't figure it out. Let's make it a little more difficult. Let's multiply by 2x over 2x, right? These have to be the same. You can't say, oh, let's multiply 2x over 5x or something, right? That will change the value, okay? We're multiplying by 1, right? What does this give us, right? This is binomial times monomial, so you multiply 3 times 2x gives you 6x minus 10x squared, and we get 2x times 4 is 8x plus 2x squared. Okay, are they equivalent? I don't know, throw the same number in both of them. Let's make x 0. That'll be easy, right? Because I can make x 0, just end up with 3 over 4. Okay, make x 0 here. Oh, wait a sec now. That can be 3 over 4 if I make x 0. No. Why can't I do that? Why can't I make x 0? So problem is, in this expression, this will be undefined when x is 0, right? Because I multiplied by something where, hey, this thing I multiplied by, x can't be 0. Right? It's true for any other value of x, but it won't work for 0. Okay? So you say, all right, well, let's throw a 1 in then, right? So I get 3 minus 5. 3 minus 5 is negative 2. And 4 plus 1 is 5. I'm going to end up with negative 2 over 5. Okay, here I get 6 minus 10, which is negative 4. And I get 8 plus 2, which is 10. And negative 4 over 10 is negative 2 over 5, which is what I got there, right? So they will be equivalent. What you got to watch out for is these non-permissible values, right? And well, here I introduced it because of the x there. Okay, let's do one more that's equivalent. What do you want to do? Uh, 40 minutes and no sign of stopping. This one's going to go long today. So. You can multiply by anything. Any rational expression that's equivalent to 1, you can multiply by, right? What's a rational expression? Polynomial function over polynomial function, right? Polynomial over polynomial. It's polynomial, well, x plus 2 is a polynomial. Okay, so this is going to give me 3x plus 6 minus 5x squared minus 10x over, okay, I'm just using FOIL, right? 4x plus 8 plus x squared plus 2x. And we're going to simplify that. I like to lead with the x squared term, so we're going to go minus 5x squared minus 7x plus 6 over x squared plus 6x plus 8. Those are equivalent rational expressions, right? As long as you don't put in one of the bad values for x, right? That's the value that would make the denominator 0. These expressions will evaluate the same. If we throw a 1 in, right? We threw a 1 in, we got negative 2/5, right? If we throw a 1 in here, we'll get negative 5, minus 7 is negative 12, plus 6 is negative 6. Make a note of that somewhere, negative 6. And down here we'll get 1, 7, 1 plus 6, yeah, which is 7 plus 8 is 15, which is negative 2/5, right? Divide by 3. Equivalent rational expression, right? You put the same number in, you get the same number out. For all of the different forms of the expression, right? Because they're all equivalent rational expressions. Okay, so that's the way you can verify equivalency. Okay, second thing we want to learn today is non-permissible values. Okay, so we've touched on it. Let's go a little more formal on it. Non-permissible values. They are very important in the study of rational expressions because they creep up a lot and they can cause difficulties when we're solving equations. So it's the value of a variable that makes the denominator of a rational expression equal to 0. The value, I'm going to say values, value or values of a variable that makes the denominator of a rational expression equal to 0. And as you remember, we can't divide by 0. NPVs, oh, what's an NPV? Non-permissible value, right? Because it gets, kind of tedious writing out non-permissible value all the time. So a lot of times we'll just call them NPVs. Are determined from the rational expression after the denominator has been factored but before it has been simplified. So what we're going to do is look at denominators. We're going to factor them, figure out the non-permissible values, and then do any simplification. And today's emphasis, really, tomorrow's emphasis is on simplifying rational expressions, right? But keep in mind this non-permissible value thing, right? It's factor, then simplify. If you have any issues with factoring, there's a few 100,000 YouTube videos, some of which are even mine, on factoring, right? So, you know, get some practice in. I'll be happy to sit down with you and go through some factoring strategies. We're not doing anything terrible. Like if you guys did 20-1, there's some like really ugly factoring in there. We don't do any of that. It's just the basic factoring that we did in 20-2, right? It's just pretty much basic trinomial factoring, but you know, you need some factoring skills. Okay, I'm going to skip forward. If you missed any part of this, the notes will be up later. Determine the non-permissible values for each and state the restrictions. Restrictions, you never talked about restrictions, you talked about non-permissible values. Now we have to not only determine them, but we got to state the restrictions. Okay, I'll show you what that is. It's actually pretty much one and the same thing. 4x squared over x minus 3. So all we're doing here, this is a rational expression, right? It's not equal to anything. You cannot solve this. Right? Hey, I'm going to solve that and x is equal to 3. No, or 2 or 1 or no. There's no value for x, right? It simply exists as, hey, here's a rational expression. And we're going to do stuff with them. We're going to simplify them. That's tomorrow. We're going to find non-permissible values. That's today. Okay. So what is the non-permissible value?
0.
No.
Oh, no, it's 3.
Right. So it's the value of the variable that would make the denominator 0. So here's what I do, right? I want to figure out non-permissible values. I say x minus 3 equals 0. So x is equal to 3. So the non-permissible value is 3. Wait for it. Here's the restriction. So that's the NPV, right? Restriction. X cannot be equal to 3. Right? It's like the same thing, just expressed two different ways. The non-permissible value is x equals 3. Right? That's the but the restriction is that x can't be equal to 3, because if it is, then this becomes 0 and the world implodes, right? You're not allowed to divide by 0. Bad things happen. Okay? Question? For you, it's just likely a loss of marks, right? It's not like a meteorite flying through the sky. You know, good thing all those Russians have dashboard cams, right? We would never have seen that thing. You know, like you'd have to be standing outside and go, wow, there's a meteor, and then reach for your phone and pull out and get the video thing, and I don't know my password. And by the time all that happens. But they got dashboard cams, so we got to see it from multiple views.
Yeah, I gotta love those illegal dashboard cams.
Well, they're not illegal. I mean,
There's something like that in Russia. There's a
well,
weird
they
law.
do it there because people do stupid things. Like, where you see the videos on. I was watching the Daily Show and the Colbert Report. They both showed the same video. So guys walking across the street, that the car comes, and he's like, the car stops, and the guy goes to the car like this and goes, you know, and then he's gonna roll off the hood and say, "You hit me," right? That's why they do that, right? So look at the dashboard cam, right? Like, come on, you did a very bad acting job stepping into the car. So, okay, yeah. They may be used as evidence against you in a court of law, though. Just be aware of that. Okay, what do we want to do? We want to say that the denominator can't be 0, right? Or we want to say, when is x times x plus 5 equal to 0? Right? Non-permissible values are when the denominator is set equal to 0. So what value or values of x will make x times x plus 5 equal to 0? 0.
And negative 5.
Okay, so x equals 0 and negative 5. Right? Those are the non-permissible values. What are the restrictions? X is not equal to 0 or negative 5, right? You cannot set it equal to 0 or negative 5. If it is, I think, because then you end up trying dividing by 0, right? Okay, so that is a factored form, right? That's factored. This isn't. 3 over x squared minus 6x. What values of x make x squared minus 6x equal to 0? Okay, NPVs, right? We say, what values of x are going to make that equal to 0? So we factor it, right? Okay, and now it looks like this. And what are the values of x? Okay, x equals 0 or x equals positive 6, right? I'm not going to show huge details on this, right? If x is 0, what value of x makes that 0, 6, right? 6 minus 6 is 0. What are the restrictions? X cannot equal 0 or 6. Most of the time we state restrictions, right? So we look at it, we say, here's a rational expression, state the restrictions, and then do stuff to it. Solve it, add them, multiply them, whatever you're doing. Simplify. Okay, let's do a bunch more, because, you know, it's like fun. Not really going to give you much time today, unfortunately, in class to work on this stuff, but the assignment's not a huge... non-permissible value. What's the NPV? Negative 4. What's the restriction? X is not equal to negative 4, right? Restrictions are useful because they say don't do this, right? Don't make x negative 4. Any other value is fine. Don't make x negative 4. Okay. So some you can do just by looking, right? So you look at this, you say, yeah, negative 4, right? X cannot be negative 4. This one? Negative 4 again? Yeah. Okay. Now that's a little more complicated one, right? So you might want to write this down. You might say, oh, negative 5. So I'm going to go negative 5x minus 20 equals 0, right? So I figure out my non-permissible value. Set the denominator to 0 and solve for x. Okay, so negative 5x equals 20, and x is negative 4. Okay, and the restriction is x cannot be negative 4. All right? So if you can look at it and just say, hey, negative 4 is what will make that 0, good. And if you need to do a little more work, fine. Right? It's not like it took that long. Okay, just got to solve that. 4p to the 4th. 2p to the 4th plus 10p cubed. Okay, so the very first thing we're ever going to do with any rational expression is look for the restrictions or non-permissible values, whatever, you know, they happen to say. Okay, how do we do that? We take the denominator. This case is a little more here, so let's take the denominator. Set it equal to 0. Let's factor it, right? It factors because 2 is a common factor. And then there's a p cubed, giving me a p, right? Because that'll give me 2p to the 4th. Okay, so divide that by plus 5. Okay, which means that p is 0 or p is negative 5, right? Once you're in factored form, it's easy to get the values, right? Well, that'll make the whole thing 0, right? Negative 5 will make the whole thing 0. Okay, restriction. he is not equal to 0 or negative 5, right? You can't put in 0. You can't put in negative 5. Okay? If you do, blows up. Three more. 3x to the 4th over 3x squared minus 7x. What is this? G. Okay, that bottom, the denominator factors, so we want to factor it. So what I'm just going to do is write 3x squared minus 7x equals 0, factor out an x, and say that x is 0, or, do you know the fast way of doing that? Positive over 3, 7/3. So the fast way of doing that is to take this number over this number, but with the opposite sign. Okay? Because really what you're doing is this. You're solving 3x minus 7 equals 0. So you got to move the 7 over. That's where the opposite sign comes from. And then you got to divide by 3. Okay, and that's where you get 7 over 3. Restriction. What's the restriction? X can't be 0 and 7/3, right? So non-permissible values are the values of x that make the denominator 0. The restrictions are just stating those with a don't make them, right? Don't use those values. Just erase this. 2 more. X to the 4th over x squared plus 4. Non-permissible value. Can x squared plus 4 ever be equal to 0? Yeah. Okay, which is another way of saying, can x squared be equal to negative 4? Can you square a number and get a negative? No. Okay, so you just say no restriction. Okay, we can never get a 0 out of x squared plus 4. It's always because x squared is always positive. And then you're adding 4 to it. We can't get 0. You're going to get at least 4. Okay, so there are no restrictions on this one, right? Sometimes there's no restrictions. And x plus 2 over 3x squared minus 12. Okay, what do we do? So we set 3x squared minus 12 equal to 0. You get two choices. You can factor this, right? Get a 3 bracket x squared minus 4. Or you can say, yeah, I can isolate the squared, right? So 3x squared is equal to 12. So x squared is equal to 4. So what's x? It's x. I mean, I say the whole answer. It's not 2. That's not the whole answer. It's part of the answer. Plus or minus 2, right? So biggest thing, when you are solving for an x squared, right, you're square rooting both sides, it's plus or minus. You cannot put positive 2 in here. You get 3 times 4 is 12, minus 12 is 0. You put negative 2 in here, negative 2 squared is 4, times 3 is 12, minus 12 is 0. Okay. So remember that. Okay, two last examples. Of the following rational expressions, I'm going to abbreviate RE, rational expression. Identify the equivalent of the following rational expressions. Identify the equivalent rational expressions. Explain why. Okay, here they are. A, 9c minus 9. B, 3 minus 3c over 243c squared. C, 81c squared minus 81c over 729c cubed. Okay, so A, B, and C might all be equivalent. A and B might be, A and C might be, B and C might be. That's really all the possibilities, right? So, which are equivalent? A and C, somebody says. Why? So why? This is I don't know if they are. Somebody said they are. I just want to get why. Why are they equivalent? Divide by 9? Okay, so 729 divided by 9 is 81, but that's a c cubed and that's a c squared. Divide by 9c. Okay, so 729c cubed divided by 9c gives me 81c squared. Okay, what's 81c squared divided by 9c? 9c. What's 81c divided by 9c? 9. Okay, so yeah, those two are equivalent, right? And the other way to look at it is you could say, well, if I multiply this by 9c, right, I'll get 81c squared, I'll get 81c, top, good, and I'll get 729c cubed. Okay. So that's why they're equivalent. You could verify equivalency by putting in a value for c that wasn't what? Because what's the non-permissible value? 0, right? And the restriction is c can't be 0. Any number other than 0, you're good. Why isn't b the same as a or c? Since a and c are the same, why aren't b and a the same? Okay, so how would you get from 81c squared to 243c squared? Multiply by 3, right? If you multiply this by 3, you're not going to get 3. So they're not the same, right? Okay. And you could also do it again by putting in a value, right? If we put in the value 1, here we end up with 9 minus 9 is 0 over 81, which is 0. We put in the value 1 here, we get 0 over 729, which is 0. If that happens, right, so yeah, okay, I'm getting 0 as an answer. Maybe I want to try a different value other than 1. Maybe I want to put in like a 2 or something where this won't work out to a 0. Okay, just to try it, because maybe you just fluked into a value where that's 0, but this works out to 0 because of something. And, okay, so you may want to try a different value. Okay, last thing. Applications. And that's part C. Josephine. Oh, let's change the name. How about Geraldine? Is an accomplished long-distance runner on her school track team. She has completed 3 kilometers of a 10-kilometer race in 15 minutes. in, what did I say, 15 minutes. She wants to finish the race with an average speed of average speed of 0.25 kilometers per minute. Which doesn't strike me as all that fast, really. Oh no, actually that is pretty fast. That's pretty fast. Well, no, wait. Quarter of a kilometer, that's 250 meters per minute? I don't think that's all that fast. Determine the time in minutes. Determine the time in minutes that Geraldine must run the remaining 7 kilometers. The remaining 7 kilometers. Okay, so to solve this problem, we're going to do this kind of systematically, right? We're going to say there's some stuff we need to know, so we want to set up a solution in a particular way, right? We're going to start off by saying, let the time needed for Geraldine to finish the race, so solution, let the time needed for Geraldine to finish the race be what? What are we going to put in there? What is the unknown? What's the unknown always? Always the unknown. X. Yeah, we could use t, right? Because it's time, but yeah, we'll go with the time-honored tradition of using x. So you start off with a let statement, right? Because you're communicating to whoever's going to look at this. When you see an x in there, that's really the time needed for Geraldine to finish the race, right? So if you see the number x, right? Okay. So, therefore, her average speed for the race can be expressed as. So, her average speed for the race can be expressed as okay, what is speed equal to? So I drive to distance over time, right? Speed is distance over time. I drive to Edmonton, a distance of 300 kilometers in 3 hours. I'm going 100 kilometers per hour. So speed is distance over time. How far is this race? What's the total distance of this race? 10? Is it 10? Okay, you're right, 10 kilometers. And how fast is she going? Well, that's what she wants to go, right? Okay. Okay, what was speed? Distance over time, right? Distance. So we need some times. So how long has she been running? She's completely running, so she's gone for 15 minutes, right? She wants to finish with an average speed of 0.25 kilometers per minute. Oops. Okay, we got 10 kilometers, so we need an expression for the number of minutes that she's going to run. So what information do we have in the question to give us her total time? Okay, well, we know she's run for 15, right? time needed for Geraldine to finish the race. So if we make that x, we would write 10 over x, right? Oh, but that's the time to finish the race, but she's already run for how long? Okay, she has completed this. She's already run for 15 minutes, and the time to complete is x, so this is really going to be 15 plus x, right? That'll be the total amount of time. And we want the distance in kilometers, which is 10, divided by the time in minutes, to give us an average speed of 0.25 kilometers per minute, right? So this is in kilometers, this is in minutes, this is in kilometers per minute. The units all match up, okay? So if Josephine wants to average, oh wait, so yeah, so that's really the expression for her average speed, okay? And then, so hang on, I get ahead of myself here, right? We're going to erase that. So the equation needed then is 10 over 15 plus x is equal to 0.25. Okay, so let's solve it. So what's x? Oops, extend page again. How do we solve this? Okay, time's running up, so we do this. We go 10. Okay, so we're going to multiply both sides by the denominator, which is 15 plus x. What's 0.25 times 15? 3.75. Plus 0.25x. Need to get the x by itself. We're going to subtract 3.75 from 10, which is what? Probably 6 1/4, right?
6 1/4, yeah.
Okay, what's 6.25 divided by 0.25?
25.
Okay, so take her 25 more minutes to finish the race. She will have raced a total of 40 minutes. 10 kilometers divided by 40 minutes is 0.25 kilometers per minute, right? And now the bell goes. Okay, so of course you'll have a little bit of homework to do at home, but you'll survive.